That pointers thing you have covered before. You have gone through that video, the pointers one. You know? You wish that pointers thing you have done before. I had sent one video now that you had gone through.
Yes, ma'am. Yes, ma'am.
Just 1 second. Huh? Somebody needs my. Just 1 minute. I have to send this one mail to somebody. Okay, let me just do with respect to stacks using pointers. Okay. Before that, first we'll just brush up some things. Um, so in array and all, what will happen is we always need to declare some space before only. Like if I want 100 spaces to be there, I need to declare an array of 100 elements. But what happens is if I declare some 100 elements of array, but only 20 elements I'll fill. Because when it is an array, it will run from a of 0 all the way up to a of 99 if there are 100 elements. So imagine that every time when I'm entering some array, most of the times only 20 elements are filled, only 30 elements are filled. Then the rest of the array space will be blank. That means you are wasting the memory allocated to that particular array. So if this is the case, then we have to dynamically let us say that if we have to declare something, or as and when a person enters, I want to make sure that he has to be there in my system. Like if there are two employees coming in, those two employees only for those two employees the memory should be created. Okay, not more than them. If there is, let us say, we have something called as student. So in student, I had ID and I had name. Now, if I want to create an array of student, I should have written something like this. Student A of 10. That means we have array of 10 elements, A of 0 to A of 9. So basically what we are doing when we have a structure called a student, it has two properties, ID and name. When it has two properties, ID and name, then we will have some other methods also, get method, set method, or something like that. But when we are declaring the object of that particular element, only if I would have written student A, then I can take A dot ID, A dot name. one variable. But if I want to store many variables, then again I'll have to go for array. Imagine that if there are 10 array elements that I can store, but space is allocated, but every time I'm doing any kind of operation, most of the used, so it is left blank. I don't want that to happen. As in when the user creates one particular object or let us say one variable which belongs to ID and name of the type student, only when he is creating a new memory should be allocated. Extra memory should not be allocated. That time we will use pointers. So here pointer is indicated by star. So if I'm writing, let us say include IO string, okay, and then this is all done. I'll create a structure or a class. When I create a class called as student, I have two things. One is I'll keep it as public here, ID, that is int ID, and I'll take string name. Okay. Now we'll take two functions. One is set data, the other one is display. Now we'll be writing void student, then set data. We'll ask the user to enter cout, enter the ID, cin ID. Then usually we give cin dot ignore. Because we'll be using getLine operator for string. So we'll be taking here enter the name. If I want to use a name with a space like Shilpa space Vaidya, if I want to use all the thing, then I'll have to use getLine cin comma name. So once we take the data, we'll just display the data by using void display. Again, student display. In this, we will just enter name and ID. Cout ID is equal to same way we'll keep name also. I'm keeping the slash in there, endl is not required here. So here we are going to keep name. This is one class which is of student ready. Now what we are going to do in main function, we are going to take let us say one object of this class. So I'll take student and one pointer object. So OB I'll take. So when we are having a pointer object, when we are declaring a OB of like two or three particular instances are there. Let us say we have three objects. Okay, we'll have OB1, normal object, and then OB2, and then OB3. So how do you directly take the elements in this? Directly go ahead and say OB1 dot set data, same way OB2 dot set data, OB3 dot set data, and so on. But if I don't know how many elements I'm going to keep in my list, but I want to go on adding it, then I can use something like stack. What does stack do? It has one variable. No? What is the variable of stack? It has two functions, right? What are the two functions in stack? In order to insert any element into the stack, what do we use? Which variable we use? And what is the function name?
NQ, DQ function.
Those are for queue, correct?
Q, yeah.
This is for stack. Stack we have something called as push and
Push and pop.
pop. These two
Yeah.
functions are there, correct? Huh. So what we'll do is once we create this whole thing, no, push and pop function, we had done it using array before. Now we will be doing it but instead of taking the integer values, we will take the student values. Now, I want to do something like this. Initially, if there is a student, let us say ID is 1 1 and Shilpa is the name. Okay. And these two in my memory, somewhere it is located in thousandth location, let us say, because every value which you store, it will have an address. Okay. After this, if I'm adding one more element, let us say if I'm adding one more element, let us say 12, and I'm adding Tanu. Okay, he will be created in some other location randomly. Let me take it as 2000. Now, what I have to do is after Shilpa's record, it has to go to Tanu's record. That means apart from ID and name, I need to have one more parameter called as next. Next means it will store the address of the next particular object. Now, how to do that? Address cannot be stored in a small variable. Address will always be stored in a pointer. So what we are going to do is we are going to take this one next thing as a pointer. This pointer will hold the address of the next location, that is Tanu right now. Okay. So what you will do, you will print ID name. After that, you will go to next location. Which is the next location? 2000. 2000 we have again ID name and next will be there for that also. So Tanu's ID is 12 and name is Tanu and then next address. Right now, after Tanu, is there any other value there? Do we
No,
have
no,
any value is there?
no.
No. If no value is there, I'll make this as null. If there is no value, then I'll make it as null. Now imagine I want to insert one more element. Now, if I want to insert one more element, let me take it as 13. Okay. In 13, I'm going to keep the name as Uvesh, and then there is no other element which is going to the next address, so I'm keeping it as null. Maybe this is created in 3000 location. When we have it in 3000 location, 2000 of next should be equal to what? Which
Three,
value?
3,000.
Correct, 3000, right? That means every time we create a new node, no? This UH is a new node right now. Every time we create a new node, its next address will be null, and whatever address of UH is there, that is 3000, will go to the previous address, isn't it? Previous in the sense, previous node will be having the address. So in this, what we are right now analyzing is initially when you are creating a particular node, initially when Shilpa was created, Shilpa didn't have any other node, let us say Tanu and Yuvesh was not created. If Tanu and Yuvesh was not created, Shilpa dot next will be null. Okay, like that. Here, what we are going to do, we created object 1, object 2, object 3. I told you that we have to keep the address also. So to store the address, you need to have student address only, but you can't store a normal value. It will be a pointer pointing to the next address. So this pointer indicates that we are storing the address of the next location. When we are creating the node, no, when we are setting the data, means first time when we are creating, we will just make sure that the next node is equal to null. Every time we create it, next node we are keeping it as null, let us say. And we will only display the, what is that, name and ID, that's it. Now when we create object 1, object 2 and object 3, ob1 dot set data is done. In the same way, ob2 dot set data is done. In the same way, ob3 dot set data is done. Okay, that means all three objects ID and name we have taken. So ob1 dot next is there, no? It should be saving the address of ob2 because we created first ob1, next we created ob2, and next we created ob3. Now, how to indicate the address of ob2? It can be indicated by ampersand ob2, like this. In the same way, ob2 dot next is there, no? That will be given by ampersand of ob3, address of ob3. ob3 will not change. See here, this is, let us say, ob1. This is OB2 and this is OB3. When you're setting the data, all the data, no, that next address will be set to null only when you're setting it. So what happened? First ID Shilpa and then ID 12 Tanu and ID 13 Yuvesh is taken. Everything is set as null. Now what did I do? I said OB1 dot next is equal to ampersand OB2. Ampersand OB2 is the address of OB2. Address of OB2 is what? 2000. So 1000, that is OB1 dot next, will be equal to 2000. This is done. In the same way, OB2 dot next is equal to ampersand of OB3 means address of OB3. What is address of OB3? 3000. So this is connected. Now, from which address if I start, I will be able to display all three records. From which address if I start? From which, yeah,
OB1 address.
correct. OB1's address is how much? 1000. So from 1000, if I start, I'll print 11 and Shilpa, then I'll go to 2000. Then I'll print 12 and Tanu, then I'll go to 3000. Then I'll print 13 and Yuvesh. After 13 and Yuvesh, do we have anything? No. Null means this whole process should happen till I reach the value null. Okay. To do that, usually the addresses are stored, I told you, in a pointer. No. So what I'll do, I'll create one student pointer star S or something. Okay. Now S will be given the address of OB1. So while what I'll do, S dot next is there, no? Till this value is not equal to null, till it reaches null, what am I going to do? I'm going to print that, what is that?
Display data.
Display function. Okay. But star S is what? It is a pointer. So pointer, I can't directly write S dot set data. It will give you some kind of a junk value in case if we do, sorry, not set data. This should be display. Instead of doing dot, whenever you are using pointer, it will be now converted to off operator. So it will be S of display. Then what I'll do is, once it is displayed, S value will be equal to S of next. Means what I did, I'll tell you. Initially, S value was indicating to ampersand of OB1. Ampersand of OB1 is 1000. So 1000 of 11 at Shilpa will be printed. Then what will happen? S value was indicating to the address as 1000, no? So what I'll do in the next allocation, S is equal to S of next, means 1000 of next is how much? 2000. Yeah, I'll come to 2000. 2000 of next, is it null? No.
3000.
Yeah, so 12 Tanu will be printed. Now what will happen? S will be equal to S of next. S of next is what? 3000. It will come to 3000. 3000 means 13 UH will be printed. Now S will be equal to S of next means now S will become null. Now when S will become null, you have to come out of the loop because there is no other element present. So you are going to come out. That's why here instead of S of next is equal not equal to null, I'll give S is not equal to null. The moment S becomes equal to null, you are going to reach to a place where there is nothing stored. So you'll come out of that particular loop. So initially what happened? S of data was printed. Then every time when you're printing the S of data, you're going on recursively noting down from 1000, you'll go to 2000. From 2000, you'll go to 3000. From 3000, there is nothing. When S will become null, you come out of the loop. So let us run this one. Let's see, okay, if it is happening or no. So ID 11 is A, I'll give 12 B, 13 C. Here 11 A is displayed, 12 BBB is displayed, 13 CCC is displayed. Okay. By using what? By using this while loop. Now this set data is there, no? I did it for only three objects. Okay. Now, what if I wanted to do it for multiple objects? That we'll do it later. We'll check it out later. Okay. For now, you can take this one down.
Then scroll down.
Okay. Tanu, this is done, no? From your end.
Yes, ma'am. Yeah, you can scroll down.
Then scroll down.
Ma'am.
Yeah.
See this OB1, OB2, OB3. There you have written three times set data, set data, set data, right?
Yeah.
Can't we write it like all the three as one set data?
No, because these three are different objects. OB1 is different, OB2 is different, OB3 is different. So you are calling set data function to OB1, set data function to OB2, and set data to OB3. So it cannot be done on it unless there is an array or something.
No,
Then
like you have written three objects for printing different understood for different printing different objects. Like you said no, your name after that my name like that.
correct.
So like is there no other options like where you can write means you are going to call the same data but you can output can be multiple like different names
No.
using one set data. You can't do like that.
It is like how you have built an apartment which is of similar structure, flat structure, let us say. But if you have to
Uh,
live in that flat structure, Shilpa will have different house, Tanu will have different house, correct? For that, there should
yes.
be space required. So this is like what I'm giving flat number 0, flat number 1, flat number 2 to these three people, but accessing set data will be individually done. If I wanted to do it as an one object, then I had to take a array. In array, what will happen?
Mm,
We will take OB of 10, where OB of 0, OB
mm,
of 1, OB of 2 will go on. Okay. But
mm.
otherwise, we will take individual elements. Hmm?
Okay.
Okay.
Yeah.
And in this, what is happening is like we wanted to give connection from one object to another object. No, that connection is happening here.
Mm.
That is
Yeah. Yeah.
this.
The connection part I understood. No, you are again like three subject objects, right? I thought you can make it as one object, some using other
No,
operators or something.
only in array we can make it. We didn't want to use array, that's why we did this. Okay, because if we use array, then imagine if I have 10 spaces, only three spaces is getting occupied, means seven space will be deleted. Means seven space memory will be wasted. It's like when an apartment, only three flats are occupied, means seven flats will be wasted. Means nobody is occupying that, no? So if we don't
Mm-hmm.
want that to happen, only when the person comes, we are going to create a flat, something like that. Only when there is a person who is a buyer is available, only then we will build a house, something like that. Hmm? So as and when we create an object, all three objects are created, we have connected a connection. Even this is not a completely proper way of implementation. I'll tell you the next one, which we will do, so that you will get a clear picture. Hmm? Right now, this much you take down. If this
Okay.
is
Ma'am, there was a problem in my program. Name was not entering.
done, show me, share the screen,
Ma'am, you are disabled.
disable, no?
What is
Check once. Okay. Scene dot ignore you have to give in line number here. Otherwise, it will take name as line. So now you run, save it and run. What is happening? Scene ID.
Oh, yes, ma'am. But
Okay. Now see, the same program I want to modify in such a way that um, I want to create an object every time and then start attaching the object. But any number of objects I want to create means we should be able to create. If that is the case, then what we'll do is every time we will have to ask the user whether he wants to operation or delete or display. For now, only insertion and display we will consider. Okay. So
Ma'am,
usually,
what
huh,
you just now cleared his mistake now the name part what you did over there?
Which one? For him,
No, uh,
for him, this was not there.
she
Seen,
ignored.
ignore. We are giving
Even
this
I
because get line means if a person gives two names, no, Shilpa, first name and last name, separated by space, then it should consider
okay.
the entire thing as one name, no? For that we are giving get line. But before get line, we have to always use seen dot ignore statement. If we are using this, we have to use this also. Hmm?
Before get line or before the see out statement?
Before cout, if you use it is better because as soon as we take the input from the user as an integer value, we will ignore it.
Yeah.
We will ignore the
Okay.
rest of them. Then directly it will come here. Hmm?
Yes, ma'am.
Okay. This
Ma'am,
one
as
also.
it has given like that, your member function was shouldn't set data expected before see out. Okay, nothing correct. Nothing correct.
Okay.
No, ma'am, correct, correct.
Okay, done. So,
Done.
we'll go ahead with this one right now. Okay. Now we will have push operation. In push operation, what we are doing is we'll take a separate what is that file only. In this, I'll take one.
What is this push, ma'am? Using something push.
Hello. Now we are taking a separate program. We will be using stack kind of structure only, but using integer value. Okay. So if I take something called as class node, hmm, in this I'll take two values. One is integer data, and in this node star next. That means it will hold the value of the next address. This is the class node. Okay. Here what we are going to do. Okay. Here what we are going to do. This class node will look something like this. One node will be there. This will have data, which is of type integer. Okay. And one next address will be there, type pointer. And these two will be one particular variable, let us say object or something. And it will have some address which is located here, let us say. This is not part of class. Class will only have data and next. Okay. Where it will be created? It will be created in some random address, which we will look into it in few minutes. First, what we'll do, when we are taking an insert function right now, we do not have any element in the stack. We do not have nothing right now in the stack. So there is no starting point to the stack. We will create one pointer called as head. Okay. In pointer head, if there is nothing in the stack, we will conclude the head node as null. If there is no elements in the stack, no, we will conclude it as null. Otherwise, what we'll do, we'll ask the user to enter one element. Let us say he has entered 11 as the element. What we need to do, we need to create one node. When we are creating a node, let us say one object or temporary item, something we have created, let us say this object name, I'll keep it as temporary. In temporary, what should happen? Temp of data should be given this element value, which is 11. And when we are creating, we don't know where we are going to attach it. So what we'll give? We'll give this as null. Okay, initially. Now, one particular object is created right now. Let us say this is in some location 1000. Okay, we have created in some location 1000 with element 11. One next node, we don't know where we are attaching it, so we are keeping it as null. And it is there in, it is created in the location called as 1000. Before we created this node now, head node was pointing to how much? Null. Means there were no elements in the list. So now what will happen? We are going to give a condition. If head node was equal to null, then whatever object you create now, that itself will become the head node. That means right now there are no elements in the list means whichever element you created, this only will become the starting point of my linked list. That is stack. This only becomes my starting point. So if head node is null, whatever temporary address is there, no, that is 1000. This will become my starting address. When head node is only pointing to 1000, that means from now onwards, what will happen? This is my head node. Means our data will start with 1000th address. Now imagine user wants to insert another data. Now element which he wants to insert is equal to 22, let us say. What will happen? 22 should go to data. We don't know where we are inserting, so we'll keep it as null. And some other location, let us say 2000th location, we have created this temporary node called as with data 22 and next as null. Somewhere in the memory we have created this. Now, currently, is my head node pointing to null or is it pointing to some value? Currently head node is there, no? Is it pointing to null or is it pointing to some value?
Some value 1000.
Some value is there. If some value is there, that means that already one particular object is present in your list. Okay. Where we have to attach this? We have to attach this after this head node. Means after 1000, we have to attach this temporary. For that, what we are going to do? We are going to take a separate pointer. Okay. I'll take a pointer. And for this pointer, no, I'm going to assign the value of head. What is the head value currently?
1000.
1000. So now I'm going to come to 1000. Okay. So my pointer P is also pointing to the address location 1000, let us say. Now, P of next, is it null? Means 1000 of next, is it null? Yeah, right. If it is null, I'll come out of the loop. Once I come out, that means I didn't go anywhere. I just came out of the loop. When I came out of the loop, P value is still 1000 only. What I'll do, this temporary item is there, no? 2000. It will be here somewhere. Now, if I have to attach, what I'll do, P dot next, that is 1000 dot next will be equal to temporary. What is temporary address?
2000.
2000. So this will become 2000. That's all. P of next will become 2000. Now, imagine we have created another variable 33 at some location 3000, let us say. Our head node will not change, okay? Why our head node will not change? Because your starting point of this list is not changing because we are inserting the node at the end of the list. So our starting point won't change. Here, imagine that we have taken one element, let us say it is 44. Now again, data will be equal to 44. Okay. Next node will be equal to null and this will be equal to 4000 location, let us say. So we have this one. We need to attach it after 2000, but right now we don't know how to do it right now. So we are just keeping it here. Our P value is there. No, we'll start from head node again. Head node is what? 1000. P is also equal to 1000. Now 1000 of next, is it null?
No.
No. Then we will do what? If it is not equal to null, no? Then P will be given P of next. What is P of next?
P of next null.
See, P is in which location right now? P is in which location?
1000.
1000. What is 1000 of next?
2000.
2000. So now P will become what? From 1000 it will become 2000. 2000 of next, is it null or not null?
Null.
Null. So if it is equal to null, no? If we are telling that this is equal to null, then we will come out of the loop. Once we come out of the loop, P is right now here. Temporary is at 4000. P is at 2000. P of next, that is 2000 of next, should be which value?
2000 of next 2000.
No,
No, 4000.
4000. 4000 is nothing but temporary, no? Means, yeah,
Yeah.
I can write P of next is equal to temporary. That is nothing but 2000 of next is equal to temporary item. This will remain as it is. Why we took not equal to null? Because only the node which has next address as null is the last node in the list. See, everywhere you go, 1000 of next is 2000, 2000 of next is 4000, 4000 of next is null. Which is this node? This is the last node. So we will keep the pointer P hopping to the last address. So now you see, if I had some 55 and this has 5,000, okay? Now we created this node, let us say. This is the temporary node. We are going to keep it here. So let me take this one here. Take this here. Like this. Okay. Now P will start with which value? 1,000. 1,000 of next. Is it equal to null?
2000. No.
No. So now P will become what? 2,000. 2,000 of next. Is it null?
No.
No. If it is not equal to null, I told you what? P will
4000.
be equal to P of next. So now this will become how much? From 2,000, it will go to 4,000. 4,000 of next. Is it null?
Yes, ma'am.
If it is null, it will come out of the loop. Okay, once it comes out of the loop, P is right now pointing to this location. Temporary is pointing to 5,000. So P of next should be equal to what?
5000.
5,000. 5,000 is nothing but temporary. That's it. So if I have to create something like this, okay, I need to go to my code. I'll create one node star head node. Okay. And in the main function, you don't take it down. I'll do a lot of changes, then you take it down. So now you don't. What I'm going to do here is I'm going to have functions. Now that function is void insert. This is a normal function. This is not with respect to any, what do you call it, classes or object. This is normal function. In this function, I'm going to send int element. That is from the main function, I'm going to send the element. Now, this one, since it is a function, I can put it after the main, and only this first line is there, no? Prototype declaration. It will come here. Okay. Let's keep it as it is. We are going to do what? We are going to take the choice from the user, and we are going to do the do while loop. In this one, I'm going to have this loop till while ch is not equal to 4. If he says 4, will come out of the loop. In this, again, we are going to say user that whether he wants to push the data. For that, we'll give option 1. Whether he wants to pop the data. Pop we have not done yet. Okay. Whether he wants to display the data. And last one is whether he wants to exit data. So enter choice. We are going to ask the user to enter the choice. Once he enters this choice, we are going to take it to the switch statement. So in switch statement, choice will be passed. In this, we are going to have case. Okay. Now this case 1 means we are going to insert the operation. So I can ask the user to enter the element. Once we ask the user to enter the element, I have to take that element, C in. Once the element is entered, we are going to call which function? Insert function. So in insert function, we are passing the element. So you have to declare the element also here. Okay. Now, after this, I will break. Now for case 2, we have to write pop function. Right now, we will not worry about it. I'll just give break for this one. For case 3, we have to do display. Display we have to do right now. So that one we'll call display function. And then we'll put a, okay. Then the last one is case 4. We are going to just come out of the loop, let us say. Now, in this case, what will happen? I'll have to write a function called as display. So here I'll write void display. We didn't discuss display. We'll discuss this right in few minutes. Okay, keep it ready. First, insert function we had. No, when element is inserted, first of all, we created a node. So when we created a node, it's a temporary node. So what we did, node star temp. Dynamically, when you're creating, no, you'll be giving something like this. Node star temp is equal to using new operator, new node. Something like this you will be giving. When you give like this, I can pass this element to the node so that whatever, what is that element you give, no, here, that is temp of data should be equal to the element passed. Temp of next should be equal to null. That can be written in a constructor here. Now, how the constructor is written? Whenever you have a default constructor means without parameter. If you have a parameterized constructor, you will take int element. Okay, this whole thing I'm keeping it as public so that accessibility will be easy. How you will write the what is that constructor? Class name, constructor name, element. We are going to give data is equal to element. Okay, and the next will always be equal to null. Whenever you are creating a new what is that memory address, no memory block, 45, if I pass, I put 45 into data, always the next node was equal to null. So the same thing, next node will be equal to null. We are assigning it to nothing. So when we did this temporary node, when we created new node of element means 55, if I give, it will go to this function. Data will become 55, next node will become null. Now this is my temporary item. I have to check two things. One is if there are no nodes existing at all in my entire list, if there are no nodes existing at all, head node will be pointing to what? If there are no nodes, head node would be pointing to null, no? In my entire list, if there are no nodes
Null.
present,
Yes, ma'am, null.
it will be pointing to null. Otherwise, new node pointing and all, it will happen based on P will be started to point to head node. P will start checking whether next node is equal to null or not. If it is not null, P will become P of next so that it comes to the last node and everything. That is all in the secondary part. If there are no nodes existing, usually when nothing is there in the list, then the head node will be pointing to null. What will happen here? We are going to check if head node is null. That means there are no elements in the list. If there are no elements in the list, then the whatever temporary you created now, that itself will become my head node. Otherwise, else I have to attach it at the last part of the list. For that, what I'll do? I'll take node star p pointer. P will be starting with head address, that is 1000. While we are going on changing this one, while P of next is not equal to null, till it is not reaching null, what we are going to do? P will be equal to P of next. Okay. After you come out of the loop, P of next is nothing but new node that you have created. That is temporary node. Okay. Temporary node that you have created. That's it. This is the insert function. I'll explain you one by one. Okay. So if there is nothing in the list, if head node is equal to null, because there is nothing in the list right now, what will happen? You have to create a temporary item. Okay, like this, let us say you created one particular object. Now, how did you create this object? By this line. Temporary is a pointer. Using new operator, you created a node. Node, what did you pass? 55 you passed. When you passed 55, it went to this one, constructor, nodes constructor here. 55 is passed to data. Next node is equal to null. Hence, what will happen? Next node null, 55 is data. And its address is nothing but 5000. If head node is null, that means right now our head node is null. From now onwards, temporary only will become our head node. Means this only becomes the starting node. So head node, if it is equal to null, from now onwards, head will be pointing to 5000. That is temporary. Okay. From now onwards, this only is your head node. Because there is no element present, whatever you created, that only becomes the head node. If it is already present, if this is not true, that means it is something like this. Means in this case, if you see, there are already how many nodes? There are already 1, 2, 3, 4 nodes present already. So is head node is equal to null? No. Then what we did? We took a pointer. Pointer started with which node? P is equal to head. P is equal to head means what? It started from 1000. So P is equal to head. Till P of next is not equal to null, we went on making this P jump from current address to the next address. So what will happen? 1000 of next, is it null? No, 2000. 2000 of next, is it null? No. Then it will come to 4000. 4000 of next, is it null? No. Then it will come to 5000. 5000 of next, is it null? Yes. If you create a new node now, it will go and attach after this 5,000. Like if I create a temporary node somewhere here, and this is 66, let us say, or 88, and 8,000 location, and this is our temporary node that is created. That means P of next will be equal to temporary. Temporary is nothing but 8,000. So we made a forward connection here. This part is happening here. Okay, that means coming to the last part of the linked list and attaching itself to the temporary. This
Ma'am,
is
head was not changing.
head will not change, because head is only, it will change only when there are no elements present. If there are elements present, starting point to change nahi hoga na.
Okay, ma'am.
Head will always be 1,000 only. If one element is there, means it is like which is the first house in your like street number 14. If there is a house, this house only will be the first house. Rest everything will follow, no, from right hand side. So your starting point will not change. Starting point is 1,000 only. So what we were changing was P. P started with 1,000. That means the starting point of the linked list. P is equal to P of next means P came here. P is equal to P of next, it came here. P is equal to P of next, it came here. So P is the one which is changing. Okay. Now, when do we say that there is no elements in the list?
Head equal to null.
Correct. When head is equal to null. So if head equal to null, that means there are no elements in the list. So we can say Cout no elements in the list. Okay. Otherwise, else we have to start printing from the head node. That is 1,000 of data 11. Then we will go to 2,000. 2,000 of data 22. Then we will go to 4,000. 4,000 of data 44. Then 5,000. 5,000 of data is how much? 55. After that, we'll go to 8,000. 8,000 of data is how much? 88. When it becomes null, we will come out. So this display function is similar to last time we did display, no, like this. Similar to this it will be. So here what will happen? Instead of taking this one, we are going to take node star P is equal to head. Means we are pointing the pointer to head node. What we are going to do till P, till pointer P reaches null, till it is not equal to null, we are going to call P of display, and P will be equal to P of next. Here we are going to put here saying that elements in the list is equal. See now what will happen. Star P is equal to head. By this rule, what does it mean? We have created a pointer P and we are assigning the value of head node right now. P is pointing to this one. I will call P of display. I will call P of display means what it will display. In your display function, in this, I have to write one void disp. Okay. Now, what will this do? Void node colon this function. Okay. In this, it is just printing Cout. What is it printing? Element it is printing. That's all. Okay. So what will we do here? We will call the disk function. P of disk means it will print the element. After it prints the element, I will just write down Cout. This will be printed. After printing the element, it will print that arrow. Then P will be equal to P of next. See in the disk function what we did. We just printed the element. That means in 1,000, whatever data is there, no, this data will get printed. Okay, that data is nothing but 11. 11 gets printed. Then what should happen to P? P should be equal to P of next. What is 1,000 of next? 1,000 of next is 2,000. So when P is equal to 1,000, 11 gets printed. Now P will be equal to P of next means 1,000 of next is 2,000. What is there in 2,000? What is the data inside 2,000? Inside 2,000, what is the data
22.
here? 22.
22.
Yeah, before printing 22, here I have put this one, okay. It goes on printing after every element. It will just print like this. Then 22 is printed. After printing 22, P is equal to P of next. What is 2,000 of next?
4,000.
4,000. What is there inside 4,000?
44.
44. So 44 gets printed. Now P is equal to P of next. Where will it go?
5,000.
5,000. What is there in 5,000?
55.
55. Okay. After 55, where does it go?
8,000.
8,000. What is there in 8,000?
88.
88. After 88, where does it go?
Null.
Null.
Entering.
Correct. When this becomes null, okay, this whole loop will only keep happening till P is not equal to null. If P becomes equal to null, it will come out. Okay, it will come out, and I will just print, means it will go to the next line. That's it. It will print till the last element in this whole list. The moment last element is printed, it will come out of the loop and it will go to the next line. That's all. So now if we run this right now, see, only push and display I have done, no? 1, 11, 1, 22, 1, 33. If I give 3 display, see, 11, 22, 33 is displaying. Again, 1, 44, 1, 55, 1, 66. If I display, it will give 11, 22, so on up to 66. Head node is, which is pointing to 11, that one, all the way up to last element. Okay. So this is what push operation and display operation. Pop operation we will do tomorrow, but now you take down this one.
Now scroll down. Then scroll down. Then scroll down.
Just 1 minute. Show me the switchcase one. 1 minute.
Which one you want?
Yeah. Done. Scroll down.
Oh.
Then scroll down.
No, in the switch case statement, didn't we use any default statement over there?
We didn't, but we should be using. You can give your own. This is taken. This
Yeah. Yeah.
is working or what you check once.
Wait.
It's done now.
Ma'am, done, ma'am. There is error in my program.
Show me the code. Here disp is given, no? Come down. That void display is proper. Come down. Here in the display function. Wait. Data checking. This is while loops thing. Part of if not. Yes, yes, okay. Now data star next to now this function. Yeah. Next one belongs to this the else part will close here. Okay, now you run this. You wish run karo.
Uh, I'm showing error, line number 41.
Even कौन सा है? 41 is here. हाँ, default statement लिखो. See out invalid choice. अभी रन कर. Insert
Line number
element. ऊपर जाओ थोड़ा. यहाँ पे int ch comma एलिमेंट दिया है ना हमने. ओके, एंटर द एलिमेंट दिया, सीन एलिमेंट दिया. ओके, ऊपर जाओ पूरा कंप्लीट ऊपर. हाँ, यहाँ पे ये डिस्प्ले नहीं है. फर्स्ट वन इंसर्ट था जिसको एलिमेंट चाहिए. देन वी हैव void display. अभी do it, run it. One, 11, again 122 you give and then display. Three. बाकी का कहाँ गया यहाँ पे. रुको.
one is showing
Showing. So the insert function कुछ गड़बड़ हुआ होगा. रुको. Temp is equal to node of element, head is equal to null temp, otherwise p is equal to head, p of next not equal to null, p is equal to p of next. ये जो है, it is not here, it is after you come out of the loop. कर पर रन करना. ये क्या हुआ अभी.
going infinite loop. Now I'm working
111, 122. अभी 3 देखो. हाँ.
yes working.
Okay. Tanu, is it coming for you? Tanu? Tanu,
Ma'am, 1 minute. Just 1 minute.
हाँ.
Just see this one error. Insert element part. Just share screen.
You have not shared, Tanu. Share the screen.
1 minute. Huh.
1 second, wait. Give me the control. You'll have to write two functions here. Write down void insert, in
Void
bracket.
int.
No, void insert. ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್. ಇಲ್ಲಿ ನೀನ್ ಪ್ರೋಟೋಟೈಪ್ ಡಿಕ್ಲರೇಷನ್ ಮಾಡಿರ್ಲಿಲ್ಲ ನೋಡೋದು. ಸೆಮಿಕೋಲನ್ at the end, enter void display. These are normal functions. void space display, open bracket, close bracket, semicolon at the end. ನಿಮಿಷ ತಡಿ. ಇದು ಇಲ್ಲಿ ಬರ್ದಿದ್ದು ಡಿಸ್ಪ್ ಅಂದ್ರೆ ಕ್ಲಾಸ್ ಒಳಗೆ ನೋಡಿ ಬೇಕಾಗಿತ್ತು. Okay, that is not, this function is different. This is different.
Okay.
This disp is
అదే
belonging.
both
already-
confused.
So here see out data, this is fine.
No, then here I have no void no display will change, right? That this
Oh, here make it disp.
just a minute.
Okay, done. So now this choice insert element, I think now it should come. Let me see. Insert int kodu, int ಕೊಟ್ಟಿಲ್ಲ. Int ಎಲ್ಲಿ? Okay. Node colon node int ಎಲ್ಲಿ?
No void ಕೊಡ್ಬೇಕಾ ಅಲ್ಲಿ ಏನಾರ?
ಇಲ್ಲ ಇದು ಕನ್ಸ್ಟ್ರಕ್ಟರ್ ಅಲ್ಲ, ಕರೆಕ್ಟ್ ಇದೆ. Wait, something else is wrong. Is that? Public.
Okay.
Public colon ಅಂತ ಕೊಡು. Spelling. ಒಂದೇ
One minute.
ಒಂದು ಎಲ್ ತೆಗಿ. ಫಂಕ್ಷನ್
ಇಲ್ಲಿ
ಅಲ್ಲ,
ಡಿಸ್ಪ್ಲೇ
bracket.
ಬರ್ಬೇಕಾ?
ಇಲ್ಲ ಇಲ್ಲಿ ಡಿಸ್ಪ್ಲೇ ಆದ್ರೆ ಬ್ರಾಕೆಟ್ ಹಾಕಿಲ್ಲ ನೀನು.
ಕರೆಕ್ಟ್.
ಈಗ ರನ್ ಮಾಡು, ನೋಡು ಬರ್ತಾ ಇದೇನಂತ. 111 122 ಕರೆಕ್ಟ್ ಬಂದಿದೆ. Okay. So pop function we'll do it tomorrow. Okay. Pop means deletion. We have not done deletion today. Tomorrow we'll do deletion. Okay.
Yeah.
Done.